And we're live.
That was, dude, nice.
Hey guys, what is up?
You need to learn about heap exploits.
Currently have
Only 2% of you guys subscribe.
Right.
nobody's on the screen right now.
Congratulations.
Oh.
Now it's infinite people.
Hi, Ron.
Hey, how you doing?
I'm good, how are you?
This is not helpful.
No, I have clothes that something like
Brett.
so. Yeah.
Now we're here. Shut up. Wait.
Looks like I can't teach. I'm dead. Can't teach him. I'm dead.
Adelaide has arrived.
That's who we're waiting on.
Yeah, now, okay, Adelaide's here, we can start.
Yeah, we were all chilling, waiting. Okay, so what are we going to be going over today? Well, we're going to, reversing, dynamic reversing. But we're also going to be going over a little bit of Ghidra today. Yesterday, I gave y'all this basic analysis one, and I didn't tell you all the stuff that you can do in Ghidra. Oops. So it was probably really hard to get this one, and probably nobody got it because, yeah, I mean, if you're Ron, maybe.
Yo, chatty out. And it's just like, hey, it's me, Cutter.
I have Cutter.
I have both. And now I'm only going to use one.
You open it in both? Yeah, so I open it in Clutter, and then I open the Clutter application in Ghidra.
I use Cutter for my function graphs and Ghidra for my function.
You don't know what you're doing? No one knows.
It's not.
I mean, it's
inside
about
the Cutter though. Like you can pull up the. It says Ghidra there.
Yeah, the decompiler is from Ghidra, but like the only time Cutter
Just
is
saying.
great is when it doesn't resolve the strings, and then so instead of being like, this is what string this is, and the decompiler is just like gobbledygook, and you're like, I don't know what this means. So you pull up Ghidra, and it's like, oh, that's that string. You can just like add a comment and Cutter.
Sloppy good.
You just get some slop for a string.
But yeah, we're gonna look at this basic analysis binary today. Let's go. Everybody get hyped.
Everybody got Ghidra installed.
We're gonna go around the room and get one hype from everybody. All right, Jack, give me your hype.
Woo, woo, woo. All right, I'm gonna get John with Ghidra. Do you have the link and everything?
Yeah. I'm putting the file with Alex.
You can have one.
He said everybody's doing.
I feel like I'm like not seeing it. Maybe that's because I haven't downloaded it.
Well,
I have this unpacked it. I run a bunch of code. But I was saying something on like the instructions, but I'm not.
If it runs, then you have the JPK. Like if you could run Ghidra, then you're fine.
oh my God.
I like the Ghidra runs.
Oh.
If Lance was here, he'd be so happy. Too bad Lance died in the fire.
Yeah. I mean, I'll put this.
So go to your browser and look up
That's what I tried to do.
just look up
Yeah,
Ghidra.
draft file.
Man, we started off Monday with like 100,000 people.
Yeah, and then I started teaching.
And then we-
Sorry, guys.
Artifacts. So
We did yesterday. Like I did.
Oh, you're good. We just did some, we learned some Ghidra stuff, we learned over types, and,
Yeah. I did that with Matt. Where's Matt?
And it's not just like
Matt said he was
keyword,
coming.
word.
I'm so
Yeah,
happy.
okay. Yes, and then we were going over like what do pointers look like, like first, like create one, and then like what does dereferencing look like. But if you're wondering, like I did put like an example like in there. I think it's reverse3.c, reverse3
Don't talk about
is the binary, so you're able to like pull it up and like GDB, like if you have phone tools or try phone debug or Jeff, you can run it and it'll like show you the code like from the C file at the same time as the binary. So then you can kind of like compare and say like, oh, like these are all the pointer can create.
So if I want to see that happening, so I run the TDC on the reverse.c.
No.
It, or do I need to just run it on like the reverse like
I think it will literally just work like if I just do, because I compiled reverse 3 with tag G. So if I just do this, oops. And then I put a breakpoint here. Run it. So it's got the C down here, and then it just has the assembly right there.
Yeah.
So you just have to have both of them in the same directory, and it works with Jeff and on debug, I'm pretty sure. So, pretty useful. But I just wanted to more get like a pattern recognition of what's happening there, rather than like just like looking at it and being like, okay, what's going on? So
Well,
yeah.
Right? Yeah, Calvi wanted to do
Sometimes.
I gotta,
I like Windows.
I gotta.
Nice.
Hannah Montana Linux, actually, that's what I want to use.
People aren't that good at securing. Oh, Cade. Oh no.
Like, can you imagine?
What's wrong?
Just got into his email.
Oh no.
Oh, Cade.
Destroy his whole career right now.
Compose.
Who are we sending an email to today? The brigade? Oh, too good of a person.
Should have just left something behind.
Usually, if I can get Jax, I'll just send it to somebody that we know.
You know the whole CSCT.
So every time you.
Nah, I wouldn't do that. Like one person, like you could like email.
Yeah, that's actually a challenge. One time I like really struggled trying to type AA out loud for passwords.
Yeah, so your username is Calvi. This is like the guest. This is like the guest credential.
Oh yeah, so again, Yidra pulled up and import the basic emails file.
Hydra. Hydra.
Hydra?
Hydra.
That's what you use?
Jidra.
You
Is
did
it a GIF or a GIF, Clay? GIF?
Clay.
GIF?
Clay.
Now you need to give a sound argument for why it's good.
Because he's Clay.
GIF as in good, or GIF as in
There is a correct answer.
Jiffy
joking.
peanut butter.
What's up, Ron?
Download the JDK there. I have it.
Download the JDK inside.
Download it and then. Well, I don't have PC.
Oh my god.
Ron
Ron is so
Did they even release Heater for
Like,
Windows?
just shut down.
Oh, he's struggling hard.
See, it's a great idea until it's like
A control C.
you accidentally pull out real malware to reverse engineer. Just care about the operating system. Then you're gonna define
You just send the kill
it.
signal.
Okay.
Okay, how about control Z real quick?
Probably also gonna do
Alright, FD.
Yeah, that's alright.
Man!
Unless you do this.
Hi. I
Matt,
don't
you
want
made
to know
it.
how to use this.
Matt, I promise we didn't start with that.
We were waiting, man.
No, literally, literally.
We're just getting started.
Try to. Did I have something else down? First thing is down.
It's like, even if it's an app package, or like it's weird, it's like open JDK, pack 11, pack
Maybe that's the problem. Yeah. Hydra. Okay, yes, everyone installed it. Yes, I have you. Why? Why?
No, you're probably on the wrong line.
No, I thought I switched it to one. Four? Yeah, I'm on the borderline. I don't know. This typically works.
So I added a little thing for you.
I'll go to the.
So now,
Yeah, that's
now all
the
you
easy
need to do
option.
is type in
Yeah.
Hydra from-
But this should be the easy option, because you can literally just type.
Yeah,
it and
you have
it'll say
either
down.
So
Five
it's
G.
pretty
Oh, so
awesome.
you're set. You're set.
I don't
So
know
we just
anymore.
we're pulling up this basic analysis binary from the
Everything is
drive
lined.
in Ghidra.
Okay.
Like when you app install cutter. it doesn't have
So
any
inside the
file.
part.
Like, why would you do
Because the bin is like the
Because
listed code.
when
Download the address, like,
Like,
so you don't have-
Brave is the ultimate one.
Or
Or
Now
Duck
we're
Duck.
gonna
I think it was searching.
Yeah.
Hey, what's the best route?
Yes.
Ron,
It's like Chrome.
Ron,
but
don't
it's
steer
not-
the leg, stop it, stop it.
It is never not fire.
So like has a built-in incognito.
You just get used to the fire hose. You're like, okay, we can do that.
Oh,
So you get
Oh, it's a waterfall.
Ron,
That's
you're
the fire hose.
Did you actually check and see if it's like set up? Cause like I'm having issues with stuff here. I was able to get it downloaded, but like. I can always try and find it.
Okay.
Keyboard stuff. Looking at keyboards.
Okay, does anyone not have Ghidra yet? Ron, are you kidding me?
We don't have Adrian either.
Just
Just
download the app.
just saying, we're trying, we're trying.
Okay, I don't like using the VMware, so I downloaded it on my normal one, and then I changed it to JGK on my USL. It's not good on the VMware.
This guy. Paul.
He doesn't, he
Paul, yeah,
doesn't
what
like
you call it,
VM.
sorry.
I hate the VMware.
it works then.
I know, so like.
Yeah, so it like boots up a process and then it starts.
Alright, so we're gonna do
Clay, are you part of the Cutter Gang?
Locked.
Are you Cutter Gang or are you Ghidra Gang?
Oh, yeah. Clay is before I was having.
Yeah, so the first thing you want to do is do file,
I don't like when it fires.
the new project.
Yeah, just
here.
In an Apple.
dude, if you're not hacking with
And-
Fred, you're not.
Just
I
click
do
the
it
next.
in Apple Notes.
I need to name it.
I do it in Apple Notes.
Whatever you want to call it, you call it my favorite number one folder, you can call it coolest thing ever, you can call it Matt.
No, go back, you,
Yeah.
you really
If
just
you
said.
can't, if you can't write.
If you
something
can't
down,
just say
you're
don't
gonna have to
go back.
run letter and like go into a file, compile it, one shot.
That's-
Get it
We
out.
need to work this time.
I feel like I have like the same hair as
I was
everybody
so
else.
much time on it.
I haven't.
Yes.
So now you have a project, you can go back into file,
Because everything,
and then there's import file.
because I have to do with
See,
So then you'll just find the binary. I don't know if you downloaded it yet.
Which one is it?
It is basic underscore analysis, and that's from the Google Drive.
There we go. Okay. Oh, is it? Oh, it's coming now.
great. Alright.
If you weren't, were you yesterday?
No, I was here yesterday. Oh, is it because you downloaded it yesterday? Yeah, I was at Meta.
Okay.
You also need to do that.
Yes.
Good.
I just want to say I
Oh,
cheer up
it's
with joy when I look at the team.
What?
I just cheer up with joy when I look at the team.
I hear it from Joy when I see you. It's just in
I thought you were going to say you cheer up with sadness.
Who would ever do that?
It's like I turn with like
Myself.
with neutral emotions when I see you. Just,
Yeah.
I just feel
Yeah.
blank.
Yeah, okay.
I don't. Like, it's not like I feel anything like strong besides like a strong like neutrality. But that's about it.
Okay, so you run is what you want.
Hey, yo, Clay. Come over here.
About the town.
Weird.
Rolling.
Was brought into existence. It was breath.
You can just start without me.
Here's the cool part. Dragon beats the bits.
Yeah, that's what it
Keep looking okay. Also, here's a great tip, Matt. Don't if it says analyze it and it says you want to say yes.
Click the dragon, Matt. Click the dragon.
What's the dragon? Oh my! You know he's ahead.
I want.
Does everybody have Ghidra working?
Don't worry about Ron. If Ron says another word, just like
Yeah.
Okay.
Just doesn't sound wrong. Ron does not,
If Ron says another word.
Ron does not deserve anything.
All right, next step. I'm not gonna click the dragon. I'm gonna double click on it, and it does the same thing. All right, this step's important. Say yes. Don't ever say no, unless you want to not have Ghidra help you. Then click on window. Click on functions. bam, now you have your whole working environment set up. What's here on the left, this is disassembly, shows all your assembly stuff going on. So this is a location of where that is. This is the actual like bytes that are in the file. This is the disassembly like turned into x86 instructions. And then this right here, I think, is the data that it's working with, and then this is kind of more stuff that Ghidra's doing. Right here is all the functions that are like function labels that are in the binary, and then the decompiler. Once you select one of these, so if I do, I'm just gonna do entry for now. Then it shows what's going on. So right now, nothing super useful, but I'm just going to give a hint here. The first step in analyzing this binary is using this search function for strings. And so we're going to not require a null termination.
Always require null.
Yeah, because why would you care? And then we're going to search, and it just looks for all the strings. It's basically like running strings on the binary, which I think y'all have done plenty of times to find flags.
Is that the answer?
What's up? No, that's not. There's no answer yet. But yeah. So we got all these strings here, but there's a lot of them. So we're just gonna type in win. Oh, it's not there. Is it this? I think I need to. I think win is a little bit. Yeah. I need to decrease my minimum length. Crazy idea. Crazy idea. Now, if we look it up, there's a string called win in there. So if we click on that, and I just click on it a few times here, and then I go back into Ghidra, it is showing me the, I think it's showing me where that is on the stack, or it should be. Where did that go? I think I need to go like right here. Okay, so this is the instruction, and this is where that string is. So if we convert this using, I right-click on it, and then I convert, and then I do char sequence, it says win, but it's backwards because little endian versus big endian. Okay, cool. So I found a function that says win. So this is like the function that I want to get to. And it's called function 004007CB.
Remember that.
Instead of remembering it, I'm going to rename it. So I'm going to call it WinFunc. You can call it whatever you want.
Renaming very important because now it's renamed everywhere.
Yeah, so now if I went back to my function labels here, I can see somewhere here it'll say that. I just don't, I'm not really good at reading. There it is.
WinFunc.
Yep, so this is the win function, you know, because it has this win. So the whole point of this reversing is to try and figure out how to get it to print out win. So,
Like this.
Yeah, now.
anybody got any questions so far? Anybody not at this point yet?
How did you rename?
Oh, yeah, good question. So at the top, I mean, mine now says win_func, but if you right-click on it, and then you do either edit function, or you'll see this like the same labels down here. You can do edit label. Either one of those, you can go into like the little menu, right-click on it, and then say edit it, and then you can change the name of it.
You can also do that in the decompiler. You can pull the decompiler real quick.
Yes.
It looks slightly different. So if you right click with the decompiler, it just says rename functions. That's what I've always done. I didn't know you could do it from the.
Yeah, so there's multiple ways to do it, but it transfers between the decompiler and the disassembler.
Yeah. So you only need to rename it in one place.
Make sure you click on function.
Now you should be able to find it. What's that?
And then you see
I got you. So you're searching for it? Okay. Can we go back to the search here? Just make sure we have the right parameters. So we need to make sure it's not null terminated in the end, and then turn down that minimum length.
We'll do 3 because we're looking for a win, which is 3. And then in your filter here, you can filter out stuff. So I just type it there. Bam, there it is. So you can just click on it and it brings you to where it is in the disassembly. So then you know, like, this is the function that like prints it out. And you can actually right click on this and then you can do convert. And you'll see the char sequence form is actually like a ASCII string, just went backwards, right? Just a little ending. So you can click on that and then it converts it into disassembly. And then I went ahead and right clicked on this label up here. That's the function label, and I did edit label. And then I renamed it to like win or win underscore function, like whatever you want to name it so that you can find it later and know like this is the function that is win. And so if you go look at your functions now, like you have all these like fun underscore blah blah blah, but now you actually have your win underscore f. So if you don't need to go back there, then you can click on it again and bring you back there.
Did you know that like that was like 5, I guess,
Or like that's going to be like, yeah. So I knew, but like you could always try and find like a string called win and like that like.
Yeah, it's weird. Sometimes
Because usually like either you're entering a password and it'll be like you win, or like you like enter the wrong one, it says you lose.
Oh, okay, that makes sense.
Yeah, like there's always some sort of like end state that is like what you're trying to get, either like adding a flag or like saying win. So
That makes sense. Okay. So
It'd be very hard if you didn't know what the end state of the program was. Wonder if we run it, what happens? That's probably something we should have done first. Watch this, it's not going to work. About the time?
Yeah, I do.
Did nothing. No, didn't work. Crazy. All right, so is everybody kind of at this same point now? Ron?
I'm still in pseudo active.
Ron.
I'm not
Damn it, Ron.
I'm at 5%.
Another country I heard from. Hit me
All
a
right.
marker.
We'll wait, Ron.
He's gonna be pseudo upgrading for the next 20 minutes.
Yeah.
They like to hate us here.
Not a big deal, Ron. All right, we're just going to leave Ron in the dust.
Dustin.
We're dusting Ron here.
Sick 'em, boys.
All right. So next thing in Ghidra is there's all this information in the head of the function. So you see like this kind of like block here. It's highlighted. It says function, and then it says what the function name is, and then it has all of the stuff that it's saying is on the stack, and then it has these xrefs. So we're not going to use the stack stuff, but I'm going to tell you what it is. So these are like what we were talking about kind of earlier in the week. These are all like local variables, and it even says like local. So like with local variables, you put them on the stack, and then you like operate on the data that you put on the stack. So this is telling you where all of these are and what their offset from RBP is, or like the base pointer of the stack frame. So like this one is hex 10 or 16 bytes away from EBP, and then you can do the math for the rest of them. But like if you're doing like a basic like buffer overflow and you want to know like what is the offset from RBP, and you pull it up in Ghidra, it just tells you what it is. So if you don't like doing math and you don't like looking at addresses, then you can just pull it up in Ghidra and it'll do it all for you, which is really cool. And then over here in this xref section, this lower one right here, these right here are functions that are referencing the current function that we're in. So this little C at the end means that this function calls the current function that we're in. So like if I click on this one, it brings me up to it, and then it shows me here that it's calling the win function. So what we're kind of doing here is, oh, and also there's a back button in Ghidra. So if I want to go back to the win function, I can just press the back button. But what we're trying to do is figure out like how do you get back to like main and like figure out how to get like this win string to print. So if we go back to this function right here, we'll see that in the references, there's nothing that's calling this function. Like there's no way to actually get to this function. And so we'll go ahead and label it to like let us know that that it's not a function that's going to get us to the end state. So we're going to call it like bad function 1 or something. So I'll go ahead and do that in here. So bad func 1. And I'll go back here. We'll do the same thing for the rest of these, the next 3. So let's see. Well, this one has something calling it. So I'm gonna leave that one for now. This one has nothing calling it because there's no C there. So I'm gonna go ahead and rename this one. So bad underscore function 2. Go back over here. And then let's see this one. Yeah, nothing is calling this one either. So we'll go ahead and rename this one. Bad function 3. Yeah, bless you, Jack.
It's a bad function.
Yep. So it looks like we found 3 bad functions there, but we found one that has a calling function to it. So I'm going to call this good function 1. So go here. Good func 1. And now I'm going to see what's calling this one. So I'm going to just go ahead and click on this right here with the mouse. And now we're in this big old function. So what's going on here? It's goes on forever. It is quite massive.
That's a big function.
All right. So you can see, though, if we look at this assembly, that it's a little bit less complicated than all of these instructions. So having the Ghidra decompiler kind of helps us figure out what's going on here. So it looks like this is also some function that we're going to need to call to get to this good function at the end. So I'm going to go ahead and label this one too. It's this one. And then good. I'm just going to func 2. And I'm just going to see what is calling this one. So I'm going to go ahead and click on that. And okay, here's something important. So see in the xref, we have these entries right here. That means that this is the main function. So for now, this means that the like libc or like the entry address goes to this function. So that means we can rename this one, and I'm just going to call it main.
You want to find the main.
Yeah, so once we found main, that means we've pretty much gone all the way back up through like all the functions that are going to be called and like figure out what's going to happen.
Find the main.
Yeah, so now that we're in main, we also see that something is happening before we call good function 2. There's this other function, and it's doing something here. So it looks like it's taking our parameters. And then these two right here, this is going to be argc, and this is going to be argv. So like, you know how when you run a program, sometimes you can give it options. That's those are going to go into these 2 variables. So this right here, this int param1 is like the number of those arguments, and this is like an array of like the arguments that are passed to the program. So like if you run something like,
Can you pull up an example C program real quick to show that?
yeah, we can do that. I think I'll go ahead and make one right now.
Yeah.
So we were able to tell that it was main because it had entry in the
Exactly. Yeah. So Ghidra is doing a lot of work for us there.
Right, so while John writes the program, what have we done so far? We started, what was the first thing we did? We opened.
We looked up like when.
Okay, when we got the file, what was the first thing we did?
Jack, what do I type after this for RB?
Isn't it char star?
Yeah.
Is it
What was the first thing we did when we got the
RV,
file?
I think.
like that?
Brackets.
Ran it. We
Is that
ran
right?
it,
I think.
Couldn't figure
It's
out
been a
anything
while.
from that.
Yeah, I just usually do main without arguments.
We got the Ghidra, we noticed that the file was stripped. Well, we should have done it before with the file command. So we run it, file command, we saw that it was stripped. So that means we don't have function names. Right, so we can't just look at our functions and say, oh, there's main, there's the win function. So we did a string search. It's a common thing to get. Once we did the string search, we were able to find the win, so like you win print, the string that was stored in, or win. So from there, we can find the win function. What we do next?
Renamed it
Yep.
so that we could figure out where it was and like reference to other functions.
Then what?
We found where it was called.
Yep.
The tree functions that are calling it. So
Exactly.
the tree.
Exactly. We climb that tree, and once we find what, we know we're at the main function.
Once you find entry, I don't know what the star stands for, but once you find like, entry functions,
Yeah.
you know that that's like initializing it.
Yep. We
So
know-
you reach like the top level calling function that like then does all the other calls. So
Was that like libc name?
yeah, I think it's like libc. It's like underscore underscore libc underscore start main. So yeah,
Don't worry about that.
yeah. I mean, it's kind of useful though to know for strip binaries, but I can teach all that super quickly because I learned that and it took me a long time. Okay, but we're gonna go over like what is argc and argv. I'm actually gonna add one more line to this. I want to, well, before here, I'm gonna print argc. So we'll do %d slash n argc. Okay, so in this code, I'm printing argc, and argc is the number of arguments for the program. I'm checking to see if it's 2, and then I'm printing the first argument. So interesting thing with argc and argv is that the first argument is always going to be the name of the like program that you're running. So like, or the 0th one in this array. So argc at minimum is always going to be 1. So now if I'm checking for 2, I'm checking for 1 argument to the program. And then if I'm looking at argv of 1, that means I'm looking for that first argument to it. So if I got argv of 0, and I'll show it here. Actually, I don't need to do a new printf. We'll do %s and then we'll put a space, and then I'll do argv of 0. And so this right here is just printing 2 strings with the new line, and I'm just printing argv of 0 and argv of 1. So if I compile it and I run it with my name as an argument, so this is argc right here. So that's this argument and this argument. That's the count of them. There's 2. And then this is argv of 0. So it's the name of the program. This is argv of 1. So that is my name that I passed to it. So that same thing is happening here. So with this param1 and param2, that looks exactly like this and this. So this is param1, this is param2. But Ghidra does not decompile it to look like that. It just looks like this instead. But yeah, so we'll rename this variable. This is argc. And this one is argv. Cool.
Do you have any questions about argv, argc stuff? Basically.
A little bit behind there, Maris.
So does it just take the program name as like the first placeholder?
So actually, it's doing kind of the same thing that we just did, where we're checking argc at the beginning, right in here. And then we're calling a function on argv plus 8. So this kind of like pointer stuff that's happening here is if you see something like with this, like a type star and then like giving it a pointer at the beginning, it's kind of like accessing an element in an array. So really what it's doing is it's grabbing, I'm pretty sure it's moving the pointer forward by 8 bytes and grabbing the next thing. So it's grabbing like the second argument of the, like what you pass to it.
Does argc and argv just pertain to arrays?
So RC is just an integer or an int. And so it's just like the number of arguments. And then argv is like the array of arguments that you're giving to it. So like in this program, I just go ahead and print argc at the beginning. And that's because I just gave it these arguments right here at the beginning of main. This is like, how do I explain? Like, you don't have to run main. Like, you don't have to have this argc and this argv thing at the beginning, but somehow it ties into the, like the command line so that it can work. So if you didn't have it, it just wouldn't do anything. Like it wouldn't matter if you gave it arguments. But because I put like argc and argb in the parameters for main, now when I run this, you can work with the stuff you give it in the command line. So like if I just don't give my name here, it'll just print out argc, but I said like if argc is 2, then print out what the arguments are. But because it's just 1 now it doesn't do that. So
Is argv your array of variable names?
yeah, it's the array of arguments that you said like on the command line. So like if let's do like 3 here, and then let's give it the second one here. So argv2. So now if we file this and then I run it with this, and then now I can give it one more argument. Oh, I forgot to print the last one. Do this. Yeah. There we go. So it's just a way of getting like arguments that are in the command line and using them in your program. So usually like you do like a scanf in your program and then like get user input, but now you can just do it from the command line. So that means that we're gonna like be running this basic analysis, and we have to pass it some gobbledygook at the beginning, but we got to figure out what to pass to it. Some gobbledygook. I learned that from Cade today. Just kidding.
I've never learned anything from Cade.
Just kidding.
Cade, no Cade.
Oh, so in can you see the TV from here? I know it's like kind of small. Oh, so I don't know how to make this any bigger. Okay, so I clicked back on the functions, and like I'm like in this function, and I can see one of the references says entry, or actually 2 of these references say entry. So once I see references to a function that are from entry, then I know that I'm in main. Is there a way I can make this bigger?
Is there a view tab?
No. Window. I did that. It didn't work.
Can you do control or Windows and then mouse wheel it? Or wherever.
Oh!
It's a little unwieldy, but it might work.
Holy.
Yeah, so
Whoa, this is like the best teaching tool ever.
yeah, so we're in the top level function here.
Yeah, go ahead and zoom in.
Yeah, so we're in the top level function here. Can you see it now from the back?
John, you're gonna have to like go to one place and then keep it still.
Yeah.
It says entry. And then that is in main.
Okay.
Coolio. So this is grabbing the second argument because it's doing some pointer arithmetic, which honestly might be a little bit beyond the course or the scope of this lesson, but just trust me on this one. You can kind of tell because it's checking if argc is greater than 2. So that means we have to pass more than 2 arguments to it. And by that, I mean you just have to give it 2 arguments or more. And that's because it's already going to be argc1, or argc is already going to be 1 if you just give it no arguments. So if it's 1 with no arguments and we give it 2 arguments, then it's going to be 3 for argc, which is greater than 2. So we have to pass it 2 things. So what is this function doing now? What is it doing? Let's see. It is, there's something sus here. So we're going to click on it, and it doesn't work there. You have to do it here. Convert. Oh my gosh. Char sequence to Negmara. What does that even mean? What does? What is that?
What is?
Argument.
Oh my gosh. It's argument.
Backwards.
Yep. So it's loading this tenegmera or argument into here, and then it's also just loading 0 into here, and then it's doing a little bit of a check. So it's checking to see it's setting this flag here and checking to see that your argument is tenegmera, or at least your first argument is that. So I think the first thing that we have to know is that we got to say basic analysis, argument, and then we also just got to pass it one more thing. And then it should work there. Oh, I mean, actually that time when I pressed enter, it did more stuff than I did last time. So if I run it without these and I press enter, well, it looks like it does the same thing actually.
To get back to how you got to, we were looking at, looking into RAX. I'm at main right now.
Okay, so I went ahead and from main, I was in the the decompiler over here.
Okay, I see it now. All right.
And then I clicked on that right. Oh,
No,
Okay. All right.
I clicked on it.
Oh, okay.
And so if you click on it, then it pulls it up over here, and then you can see the decompilation of 4.
Oh, okay. So we rename it.
Yeah, we should rename it. That's such a smart. So we'll go ahead.
Such a smart
Such
guy,
a smart.
So
Smart.
what should we rename this one? Maybe like argument check, or even arg.
Or Venus cat.
Nope, don't start doing stuff like that. Lance was doing that over the screener, and I was like, he was just naming variables like Bingus and
Of course he
Bingoldopper
was.
Wednesdays.
Boy.
He did have a Ray boy. Yeah, we're trying to stick with naming.
GGB Cruise, Charlie never named part of the thing we were developing. Just like it was like half the project, and he named the main wrapping function just like John, like JAWN. Just like, yeah, we got this John here. Just all this thing. And, like,
I now have
said
my
super
idea for
whack.
what I'll be doing.
Yeah.
You want to go to John?
I've got this John here.
John?
He's like, yeah, the web scraper gets called by John, and then like it's gonna like make this post on Reddit and
Catchy.
start the backdoor.
Catchy.
Yeah.
All right, cool. Let's learn a cool little trick here too. So I'm pretty sure if we run this basic analysis in GDB, if we try and set a breakpoint at main, it's not there. What the freaking heck? So there's a cool little instruction you can do in GDB called start I. If you do this, it brings you in to the start, but we're only at this underscore start right here. So we kind of need to figure out where our main function is. Luckily, we can do that kind of easily. I'm going to set a breakpoint at libc underscore start main. And it has done that now. Awesome. Yes. So I think we can continue. And then, so now that we've broken at libc start main, it has given us the address of main right here. So we can go ahead and be star of this bad boy. And I just middle clicked it to copy it. And now there's a breakpoint there. So now when we continue, we break at that. And though it says this little question marks, like where the heck are we? If we look at where we currently are, so I'm going to do x/10i, that'll show us 10 instructions, and then our IP. Then we should be kind of seeing the same stuff like in Ghidra. So we can compare really quick. And I can look at, I don't want it in the upper right-hand corner. We can go back to our main function and see, does this look like this?
Yes.
Yes, it does. So we have found main in our dynamic analysis of the binary. So cool. So that's a good way of, like, if you are having trouble looking at it in Ghidra and you want to start looking at it dynamically, you can use that start I and then put a breakpoint at libc start main. And then once you hit the breakpoint for libc start main, then like in Ghidra, in GDB, you'll see at that breakpoint, it has this argument to libc start main that tells you where main is. So super useful.
Yeah.
Yes, sir.
How do we get to the win function?
How do we get there? Well,
When we were first starting, how do we get to the win function?
You're gonna go use your search tools and not require null termination.
Okay.
And then, I don't know what an ideal amount of characters is. I mean, win is 3 letters, so less than or more than or less than or equal to 3, but like,
Okay.
I don't know if that can backfire in other programs.
Sure.
Yeah,
Just
you're
get what you
gonna
want.
make sure that you can look at win, and then you're gonna search all your strings for win. Click on it, it'll take you to the function, and then from there you can look at other functions that are calling it to kind of do some detective work.
And then TJ, how do I know when I've reached main?
Use my entry functions.
Perfect. In the XREFs, right? Those cross references. Ron, what is the first thing I do after I run the file?
Oh, then you do like file length, and it tells you like what type of ELF it is.
Yep. And then what if it's stripped? What does that mean?
Strip means that the functions don't have names.
You guys are look at these guys.
and so if there's no labels, but we still want to go to main, how do we do that? Instead of setting B main.
You can do B libc start main, and then libc start main has an argument that says like main equals, and then a pointer.
Adley,
that
what do we
pointer
do
is
before?
pointer
What do we do before we can break libc start main? There's one thing we did right before that.
So I just opened it up.
Injury to main.
Yeah, because here's something. If I do this and I try and just run it, then it just runs it, and then I don't get any chances to look at anything. If we do that, there is no main.
How did we get into the program and just like barely be into it?
Start I, yeah.
Good job.
So if I do that,
That gets us to the very first like little instruction in the program. And so then now
Then-
we're running it.
what did I set a breakpoint at here? libc start main, yeah.
Beautiful.
So libc is double underscore.
Yep. So double underscore libc underscore start underscore main.
These aren't like this process isn't universal, but it's good to kind of have a framework.
Yeah. So pretty much anything that is like if we look at this file and we look at this is basic analysis. So back to like Ron said, we can like look at this with the file command. If you look, it says it's stripped, but it also like because it's an ELF, like ELF means it's an executable and linkable format. That means that it is wrapped with like the Linux library, and so that means you're going to be like you have these library functions like libc start main that are going to be getting you into it. So if it was like some sort of like if it wasn't dynamically linked, then maybe it would be a little bit harder to find. But because it's dynamically linked and it says it there, that means that we can do this start I and do this little trick. So let's get back into here.
Sorry.
Oh, you're good. You're good.
Everyone knows everything.
Everybody knows everything. Good. Break for the day.
Did you finish your upgrade?
I did. I gotta go take the flight down now.
Good luck, Ron.
Yeah, Ron. Hey, hello.
Oops.
Bye, Ron.
Ron.
That's where you look for the next 10 instructions.
So once I put the breakpoint in, so this first one that I hit is libc start main, and it's telling me that this is main.
Oh, I see that now.
Yeah, and so then I set a break at that, like that.
So when we rename it in Ghidra, it like automatically goes over here.
To GDB?
Yeah.
No, it won't. So it'd be really cool if it did that.
Hasn't
it's dynamically linked into the ELF, the executable and linkable format.
I just saw the RC and RP. So I got.
Oh yeah. See, and like that's because it's like calling main. So like if you like were to look at like the frames, like libc start main is kind of like entry. So it's like it's the one that calls main and then main does all its stuff. So then if we break and go here, then we're breaking at this right here, which is the address that I got, and it says question mark, question mark. I don't know what the frick that is, but that's why I did like the x/10i, so I could kind of look at when I did money RIP. RIP is the instruction pointer, so it's just like where I'm at right now, and then using examine with I right here means instruction. So like this is like examine 10 instructions from the instruction pointer, and that means so this like arrow right here. Yep, thanks. The arrow right there is like where RIP is pointing to, and then there's 10 instructions here. So I just like confirming that we're at main to make sure we got in there. What was I gonna do from here? I actually didn't really think about what I was gonna do from there, except for like maybe if we wanted to dynamically reverse it, but don't think we need to do that because in our decompiler, if we go back to argcheck here,
RJ.
then we can go back to argcheck.
Okay.
And so we're just gonna look at it. We're just gonna look at it with our eyeballs. So
It's tripping.
it's grabbing this thing right here, FS offset. Don't really know what that is. File system offset. Who cares though? The big thing to see here is that it's doing this thing where it's setting this thing equal to 1 after a check. And I think the big thing we want to get from here is that we want that thing to happen. We want this iBar1 equal to 0. So we want to make sure that this stir comp that's happening, which is taking our parameter that gets passed here, is equal to this local 28. And we already found out that that is Tenegmara, our argument. So we need to set our first argument to argument. And so the way we do that is we can actually run this, and you can just give it argument. Also, the other thing we got from there is that back in main, it is looking that we have more than 2 arguments. So we need to have 3, but that's including like the name of the program itself. So we just need to give it one more thing, but it can be anything we want. So like that's the first step, at least, into figuring out what's going on here. But once that happens, so we've done this, now we need to like actually go into our function here and start doing stuff. So this is our good function 2, which is the one that ends up calling good function 1, which is the one that calls win function. So we have to kind of work towards it, towards these functions. So we see it, we've got all these variables. It says to false. We grab the time, and then it says got the time, and then it's doing a get character, and then we grab the time again. So what is happening there? Well, so, and then also this line right here. So we grab the time. We're going to say this is time Tim 1. Yeah, I'm 1. And then, well, this is weird. And this is time 2. So,
Can you stay at that zoom level without having to hold down the key?
yeah, I can just move my mouse around. Nobody throw up. Okay, so, and then it's taking the difference between time 1 and time 2, and it's putting it in here.
Oh, I remember this one.
Yeah, so I'm going to rename that just
Good time.
div time. And then, cool. So it's getting the difference in time between when it first grabbed it and then after the get char, and then it is trying to see if that is greater than 3 and less than 7. So when it was doing this this whole thing where it's like waiting, like the amount of time is actually being recorded until I press enter. Is kind of cool. So we need to press enter between 3 and 7 seconds. And then it's actually doing a few more of those. So it does the same kind of thing right here. And here, I'll zoom in. So it's once again getting the difference between the times before and after I get a character. And then it's checking that that time is between 0 and 4 seconds. So you can pretty much just press enter immediately on the second check. And then the last one is checking that is between 4 and 8 seconds. And then it's saying if this and this and this. And so what are these things? Well, they are these flags that get set here, true, true, and true. So if you meet all of these different times, then all those flags will be true. And then you'll go into this this function right here. So
What the hell is that one?
what the freaking heck is that? Okay, well, let's click on it. Oh, snippity snap. What is going on here? Okay, well, first thing we see is srand5, and we also see rand. So we can already tell that it's generating a random number. So what is it doing with that random number? We also got a for loop, and it starts at 0. It goes up to our param1, and then it gets added to. So it's just iterating for the param1. What is param1 again? Param1 is all the way back in main, which is right here, which is argc. So if we're doing it right, argc should be 3 because it needs to be greater than 2. So if we go back there, which was in here, and then, sorry, wrong one. Go back. It's in here. Let me scroll back down, and then we look in here. So this is going to be getting 2, and so it's going to get the random number, and then it's going to set local 10 to that random number mod hex 32. So really what that means is we're going to have to write a quick little C program to figure out what this local 10 is that's getting returned. Luckily, even with random, if you know the seed of random, like seeding random means like it's kind of like start point for generating random numbers. So if you seed it with like a known number, then you can just get those random numbers that are being generated. And we can go ahead and prove that really quick. So what I'm going to do.
Can I just like interrupt?
Yeah.
The way RAM works is like imagine you're like 1923, like 86. Like this is not really how it works, but like the concept is the same. Like one. Like if I had this, if I seeded the rand at 0, then it would start like this would be the first random number, this would be the second random number, third, fourth, fifth. And when we seed the rand at 5, like this is going to be the first random number that's generated, and then sequentially like more randoms after that. And it's like there is a pseudo random number generator, but for most, if you like don't know the seed, then for all intents and purposes, it's a random number thing. But because we know the seed, we can now see what the first couple of randoms that are going to be generated are. That sound right, John?
Sounds about right. I also have to include standard lib so I can use that screen.
How big a point is including a seed? So like, I'm assuming that you didn't when all the numbers were
You just start from the beginning.
You have to seed it, don't you?
You do. And so usually they'll seed it with the current time, but that's so you just get random numbers every time. Now, if you're just trying to generate random numbers, it's fine to seed it with the current time, because at the end of the day, like it's just because you want random numbers. But if you're making random numbers for security purposes like this, seeding it with local or the current time isn't the smartest thing to do, because the person running it can just seed their random generator with the local time too, and then figure out what those random numbers being generated are. So It's only you only really want to seed it with the current time if you're just trying to get random numbers that are different like every single time you run the program. Because if you ran this program multiple times with this seed right here, then you're just going to get the same values every time. So I don't do that. Just kidding. And then so we're gonna have to give it a param one. So I'm just gonna go ahead and say, so we're saying it's gonna be 3 because we're giving it 2 arguments, and then it has the program as 1 argument, so it's gonna be 3.
Nope, I don't have it. Not my thing.
I don't do that.
I'll drag and drop, but that's the extent.
I don't even do that anymore.
John.
Hey, it's not a big deal. I just don't know how to type, you know. Oh look at that, Jack. You didn't catch me flying out there.
Whatever.
All right. And it doesn't do anything with it. Yeah, that's awesome. So instead of returning it, we should probably print it out. Cool. So look at that. It does the same thing every time, even though it's called rand. It's seeded with 5, so we get oh, 10.
10.
I don't know why that is such a big difference there. Oh, yay! So
You did it.
yay!
Yay.
So it returns 10.
That's so cool.
Right to now.
Local 10 returns 10.
That's crazy.
Oh my
You don't even
God.
need to rename it.
Yeah, I'm just gonna leave it. So then it passes that to our good function 1, which does this. And so it's passing 10 once again to win function. And then what is it doing here in our win function? What the freaking heck? What the freaking heck? So what's this right here? I don't know what that is, but we can convert it. Oh, that's you. Cool. Is there anything else going on here? Oh, so look at this. It's asking if our param 1 is 1A, but that's in hex. So that's like 26, right? That's 26. Yeah, so we're gonna need a few more arguments then. So let's go into here, and we're not gonna need 3 arguments. Let's see. Do we need 4 arguments? That's 22. So yeah, that's not what we want. Maybe it's 5. There's probably a better way to do this besides just compiling it every time, but 26 looks like that's right. So we're going to need 5 arguments, and the first one's going to have to be argument. So like when we run it, and that's basic analysis, we're going to have to give it argument, and then we have to have 5 total. So we're just going to go up to 4. So basic analysis is 1, argument is 2, 2 is 3, 3 is 4, and 4 is 5. Well, 3, 4, 5 there. So now when we do our stuff, I don't think I got the timing there right, but yeah, it doesn't matter that much. So we got to go back to
You get to click it slower the first time because wasn't it like 3 to 7?
yeah. So I was a
And then
little
0 to 4 and then 4 to 8.
Yeah.
I was a little quick on that one, huh?
Yeah.
Where is this function again? It's not there. I think we can just go back to main. Go here. Yeah, it's this bad boy. So looks like if I do this, I need to do it for 3 and then 0 and then 4. So 1, 2, 3,
Tree.
4, and then just now, and then 1, 2, 3, 4, 5. You win. Ta-da! So crazy. If you didn't like follow along completely during that whole thing, I don't blame you. A lot of it was like C coding stuff, which is like that's hard. But at the end of the day, like it was more about learning about like what can you do in Ghidra. So don't feel alarmed if you're like, I don't freaking know what the heck argc or argv or what libc star main is or any of that. Like at the end of the day, what you should be focused on is like what we did in GDB, like renaming stuff, like following X references, like, and then using the decompiler. All of that is kind of like what you should have gotten out of this.
Popcorn things you can do in Ghidra, starting with John.
Oh, me, John.
Yeah.
You can rename functions to help understand strict programs.
Yeah, that's good.
I'll call somebody.
Got one of his names.
Adley.
Adler?
Adley.
Adler?
Yeah.
You've been popcorn.
You've done been popcorn.
Boom! What can you do, Adley?
You can search for key phrases to find, like where the end might be. So
Yeah.
you work your way from the bottom to the top.
You can search for strings. You can search for like strings that are in the program.
Search for strings plus link.
I guess it's the same thing as just doing.
Yeah, I did that.
Yeah. So you would also see it in here somewhere. Argument H. Also, this is why you should look for things for that.
Search. And then strings is the last one.
Popcorn somebody had.
Now that you know that when is in the strings, what do you want to do with it? If you're just using
The strings command, like from the here.
yeah, if you're just using this, not like Ghidra.
Yeah. So then you would use the fact that you know when is there and go into Ghidra and then search for strings.
But would you do it? You'd have to go into Ghidra to do it from just like
You could go to memory address, I guess, and
I mean,
really don't.
you might be able to search for it in there, but it might be kind of hard.
use Ghidra. Go to you, popcorn.
You can like look at the decompiler to ignore all the scary stuff on the left
Yeah.
side.
Well said.
It'll jump to what you need to do, and you can also do that.
Nice. Popcorn somebody.
You can trace your way back to main by looking at functions that get called from when you find strict search.
Nice. Popcorn somebody.
So,
You're the last one, Matt. I don't know.
So you see that cute little number that starts with 0x that's green? If you right click on it, you click convert.
number.
You can change it to whatever flavor you want.
Oh yeah, baby, that's awesome. So if we did unsigned decimal, bam, now it's 1 instead of 0x1. That's helpful.
That I thought was the coolest part of it.
Yeah, actually, that is super useful though, because
I didn't
those.
know you could do that.
Yeah, and like the strings that we found, like Tenegma or argument, we had to do that because we didn't know what the frick it was. So yeah. Yeah, that's a pretty good. Those are kind of all the important things we wanted to touch on. Then all that C stuff, you could just brain dump it until you get to a class where you learn about C.
Wow.
So
You can isolate variables that you need.
Oh yeah, popcorn mares.
But,
Popcorn Mash.
okay, you can isolate variables that you need to remember and possibly use later by renaming them.
Yes.
Funky things like time 1 and time 2. And maybe if you got me Binkus cats.
Don't do that. Don't name things Bingus Cat.
One.
Yeah, Tim one's a good one.
Timmy Turner.
Timmy Turner one.
So honestly, I hadn't planned for this to take this long, and I don't mind that it went this long. But I also did put a few more things into here for y'all to do. Now, what did I put in here? There's this intro reverse 3, which is from a CTF I found that I'm not going to tell you what it is because I don't want you to just go looking up the write-up for it. And then I also put in this chall.s. Now, I'm going to help you get started on this one. So both of these are dynamic reversing problems. And I want y'all to remember, like when we did dynamic reversing, like you can pull something up in Ghidra and you can look at it and you can try and figure out what's going on. But when you do dynamic reversing, you'll usually do that with something that's like a password check. So like there's no password in the one we just worked on, and that's why we had to look at it in Ghidra. But if there's something that's like asking you for a password, you can usually guess that there is at some point in the program where you are comparing like your input to what the like program is looking for, and so you kind of want to like put a breakpoint there in GDB, and then you can see like what is it checking like for my password that I entered. So I'm gonna help you all get started on this one because you have to compile it in a special way. So I'm gonna name this Terrence's favorite.
Remember earlier this week when we were at break at that compare to see what the registers with EAX and EDX were? That one problem we did earlier in the week. It's a pretty important paradigm.
The first thing you want to do with this, sorry, it's not called Chawl anymore. It's called Bingus. And so we're going to compile it with this TAC-C option because we have a .s file. And then we're going to output it as a .o file. That's the first step in compiling it. And then we can take that .o file and compile it without any options to just Bingus. And that means that now we can run it. Now, this one, the trick is no matter what you enter, you get correct, you entered the flag. So that is not the end state of this program. You have to figure out what it's actually checking for. But trick here is that use GDB on your file, and then from there, get started. So, huh? I would not use Ghidra for these ones because I started working on the second one that I gave y'all, which hint hint, it's from Pico CTF. This the one that I just showed y'all is from Pico, but key here is that there is a where is it? Let's see. So we're in main. Pretty sure there was a stir comp at some point. Oh, it's mem comp. So, yeah, this part of the code is what's going to give it away for y'all. But I'll let you do it on your own and see if you can do it. And then the other one is just a zip file that I put in here. This is the one from the unnamed CTF that I won't tell you about until one of y'all figures it out. But you can go ahead and download this, and I'm pretty sure the did I already get it? Yeah, I already got it. Unzip this, and then if you run this, then it asks for a password, and then it knows if it's the password or not. So 2 password checking ones that kind of prove how effective dynamic reversing is. So I'll unleash you all on those, but we also don't have a ton of time left. So you can do this in your free time. You could leave now if you feel like it, or you can grind for 15 minutes and figure it out and be a cyber god.
So you combine, it was a .s, and then you made the output a .c.
A .o.
.o.
Yeah.
And then you made the .o, and you push it out as executable.
Yeah. So I took the .s file and put it out as a .o, and that is actually with the TAC-C option here. Right. The TAC-o option is just like what you want it to output as. So I said Bingus.o, and then you can just compile it with no options from the .o file into your binary, and then run it. And if you put in anything, you get the right answer. Cool. Anybody have any questions about today? I think y'all got it pretty solidly there with the Ghidra stuff.
How do you download Jeff?
Jeff. So I think I put a link.
Yeah, I'm at the GitHub.
Oh yeah, so I think if you're in the GitHub, then if you scroll down, you can do this instant setup one here, or you can then you can run. There was no, they don't have it in here, but then you can just like literally run like this right here, and it should get it for you. The prereq for this one is you have to have curl, so you could do like a sudo apt install curl and then get that, and then you can do this line of code.
Is there anything you can do in like GDB that you can't do in Ghidra? Would it be like an advantage to using?
Yeah, so like with these password checkers, like if you were to look at them in Ghidra, you will not find, or you might find the password, but sometimes when you're doing a password check, they don't just like have the password sitting there and then like compare the password that's in like the binary to like your input. So like they'll do something like XOR it with a certain number, or they'll like do certain operations on like just like some bytes and then compare that to your password.
So you can't like run it.
No.
Okay.
So the trick with like dynamic reversing in like GDB is that you can get to that point like right when it's done all those operations and then see what it's comparing your input to. So like instead of having to look through Ghidra and you're like, oh, it's like taking each byte of this like thing that's stored like on the stack and multiplying it times 2 and XORing it and dividing, and then you have to by hand or like make a script to like try and figure out like, okay, what is each of these values? You can just go into Ghidra, into GDB, let the program like run it itself and just look at the values that it's like generating. So maybe I'll just give you all kind of like a hint about the power of that. We'll look at this the CHAll one or the Bingus one. Okay, thank you. But if you go in here, Bingus, I put my breakpoint at, actually, so if we disassemble main, I said that like the key here is with this memcomp. So if we put a breakpoint at main plus, and then that is at 385, we run it. I'm just going to give it Jack's name as my password. We break at the memcomp, and then if you scroll up here, you can see Jack Metcalf's name, but then you also see the beginning of a flag. So RCX, RIX, and then RDI and R8, and then also this RSI. So we can see in our disassembly that we're moving something to RSI and something into RDI. That's because before you call memcomp, you need to give it the arguments for what it's comparing. So those arguments are in RSI and RDI. So all we really need to do is just examine for a string at this address that's in RCX. So we can do RCX, and there's a flag there. So if we had looked at this in Ghidra, like we would have been like trying to figure out like what all of like this stuff was doing with all of our kind of stuff that's going on here. Like, look, it's got all this kind of byte stuff going on at the beginning, and we could have sat here and like made a script and reversed it, and like that would have been great. But we solved it in like less than a minute by just looking at the call to memcomp and then just looking at what were the arguments to the comparison.
You used RCX because it came first before the column was the first source.
So you could use, I think, RCX, REX, RDI, or RSI. The way I was looking at it is I saw that Jack's name was in REX, and then I just saw that the beginning of the flag is right here in RCX. You could also use RSI, like if we do. And it also has it. So it's in 2 places right now, or in 2 registers right now. But yeah, that was not bad.
So I set my breakpoint to just like the instruction that calls memcomp,
Bye, John.
and it like spit out the arguments. Oh, never mind. It says it guessed the arguments, but it spit it out like immediately. Is that normal?
It spit out what immediately?
Yeah, I just wanted to.
So I put a break at memcomp, and then it just when I ran the program, it just spit it out like that.
Oh, well, that's sick.
Yeah, so
Yeah, it says arguments guessed over here, so
Yeah, so these are the arguments to memcomp. So that's sick that it did that for you. Are you using Jeff or are you using PwnDebug?
I have both on there.
Maybe they just worked together to
Yeah,
figure out what it was.
This thing here,
They're just like, we
It was
solved
like-
it for you.
it was giving me a bunch of commit like
See you guys
arguments
later.
don't exist.
names.
Yeah, so there's your hint on why dynamic analysis is so important. So I'm pretty sure if you apply the same kind of technique to this one, it's an intro rev. The write-up on this one was like figuring out what the reversing is. I'm pretty sure if you just dynamically like look at it and you just look at right before a comparison in there, you'll figure out what the flag is too. So, but we will call it there for today.